Now let's see how you can define the volume of a parallelepiped. So we've discussed earlier that the triple scalar product represents the volume of a parallelepiped having u, v, and w as its conterminous edges, right? So the vectors u, v, and w are basically the sides of the parallelepiped, and the triple scalar product will give you the volume. So let's see, this is the shape over here. So you have the base as u and v, right? In this case, this is v, this side is v. So obviously this side is also equal to v, and this side is u. And so obviously this side is also u, as they are parallel. And so now the third side that you have left is this, right? And this is w. And so this is also w. And again, you can find out by seeing that what sides are parallel. So obviously this side is also w, this side is also w, this side is v as it is parallel to v, this side is also equal to v, this side is equal to u as it is parallel to u, and this side is also parallel to u, so this is also equal to u. So you have this, let's just take this one right now. This is u, and this is v, right? And let's say this is w. Now that you have these three sides, you can see that the triple scalar product u cross v dot w is basically just equal to the magnitude of u cross v into the magnitude of w into cos theta. The angle between u cross v and w is theta, right? So in this particular case, u cross v, the magnitude u cross v basically gives you the area of the base parallelogram, right? Because this is u and this is v, and this area, the shaded region, is basically the magnitude of u cross v, right? So it is basically the base, the area of the base. And the height of the parallelepiped is equal to the magnitude of w into cos theta. Why? Because this side is w, right? And the angle between u cross v and w is equal to theta. Why is this line equal to u cross v? Because it is parallel to the plane of u and v, right? This is the plane of u and v, the shaded area. And this vector over here is perpendicular to the base u and v, right? So this is u cross v, and the angle between w and u cross v is theta, right? So w cos theta would give you this height. Let me just erase the lines that I have drawn over here, right? This height over here is basically equal to w, the magnitude of w into cos theta, and theta is this angle. So that is the height of the parallelepiped, and you just have to multiply the two to get the volume of the entire shape, which is the parallelepiped. Now, there are other ways to do this, right? You can take the base as v and w. So if you take the base as v and w, you take the cross product of v and w, and then you multiply the resultant, the cross product. You take the dot product of the resultant with u, as u will be acting as the height in this case. And let me just show you. If you take v and w, right? If you take this v and this w as the base, so this will be the base. In this case, u will be the height, right? And the third case would be if you take w and u, as the base, right? In which case, well, let's just for simplicity's sake, let's take this W, right? So this is W and this is U. In which case, you'll take this as the base. And then when this is the base, this V will act as the height, right? So in that case, you take the cross product of the base, the vectors that form the base, W and U, and then you take the dot product of the resultant with V. So these are the three ways in which you can basically find the volume of the parallelepiped formed by U, V, and W.